that you picked up when you walked into class today. It says that we're going to wrap up P7 tomorrow, which we will do tomorrow. Okay. It also says that tomorrow you're going to take a formative assessment on P1, P2, and P3. Okay? 2, 3, maybe 4 at most questions on P1, 2, 3, maybe even 4, maybe even 5. Side note, yesterday we did P5 in class. We hammered out P5 for the first 3 mods. And then we said that it is up to you to do P4. Okay? So the page for P4 is yours to do on your own. You will be tested on it next week, Wednesday, here in class. You return to the paper and pencil test. Okay? Yesterday, you also should have grabbed a yellow homework packet, okay, for P1, 2, 4, and 5. That yellow homework packet will be collected from everyone next week, Wednesday, day of test. Okay? Be sure that you check your answers. The answer key will be posted very shortly onto the It's Learning. And if you just give answers only, we will give you no credit, and may somebody have mercy on your soul. Okay? If you use the photo math, we will give you no credit. And I don't even want mercy on your soul if you use the photo math, because I'm sick of the photo math. Okay? Right? So you do your work. Yes, you need to show said work. Okay? Right? Don't trust photo math or anything like that. Okay? So that's basically what we talked about there today. Okay? So that's what we got going on. You should all have a graphing calculator by now. You should all have the P7 notes. Okay? So before we go into hardcore figuring out what the P7 notes are, what I would like you to do is I would like you to take a minute or two to figure out one of the 2 definitions of an absolute value. Okay? There's the mathematical definition, and there's the street definition. Okay? All right? So you, at your table, figure out 1 or 2 or both of those definitions. Go.
Yeah, you're on.
Are you like recording a video for
Yep.
Street.
Does it have like a microphone?
Yep.
No!
No video, just mic.
Just microphone.
Just
Can
mic.
you hear what we're saying?
I don't know, the microphone's right there. All right, somebody, give me the one of them. What do you got?
It's just its distance away from 0.
That's it? Or in a specific, on a specific thing?
In general.
In general?
Yeah.
Or on a specific thing?
On a number line.
On a number line, yeah. So that's the mathematical definition. It is the distance. A number is from 0. Math definitions get wordy. On a number line. Okay. Anybody come up with the street definition for it?
Negative number, but it's actually positive.
So just make it positive? Yeah. Street definition, we just make it positive. So an absolute value, we just make it be positive. Okay? Right, love it. So now let's dive into the wonderful world that is absolute values. Okay? So what this first part A is saying is, in words, it's saying what values, what numbers, if you will, are 5 units away from 0 on the number line. Okay? What numbers are 5 units away from 0?
5.
and
-5.
5 and -5. Okay? So we take one, and that's how we're going to go about, and we're going to solve absolute value equation. You take what's inside the absolute value, and you just set it equal to whatever the other side is. And then you take what's inside the absolute value, and you set it equal to the opposite of whatever the other side is. Okay? In part B, part B is now we're dealing with an inequality. So now our wordage has to change a little bit. Okay? So in words, part B is saying, I want all, because now it's not just one or two, I want all of the values that are more than 5 units away from 0 on the number. Okay? Well, that's going to start us at -5 and +5. Because those two are 5 units away. Okay? Now, do I have, thinking back to earlier this week, do I have open dots or do I have filled in dots? Open because we're not in the equals component yet. And I want to be more than 5 units away, so that's going to be going to the outside. Okay? So that is what the graph looks like. The interval notation for that would be from, so we'd start, with interval notation, we start left and we work our way to the right. So that would be -∞ to -5. And I've got two of them, so I'm going to union them, okay, with a big old capital U. And then that's going to be from 5 to positive infinity. So that's the interval notation. And the graph, or the number line graph, if you will, for absolute value of x is greater than 5. Absolute value of x is less than or equal to 5. Now I want all of the numbers that are less than 5 units away from 0 on the number line. So again, I'm going to start at -5 and +5. Open or closed dots this time. Closed this time. And now I want to be less than 0 units away, or less than 5 units away, excuse me. So that one's going to be a handle. We've got a rowing of the boat, and we've got a handle. Okay? This interval notation would look -5 to +5. Good times. Questions, comments, concerns, clarifications? Look, I think that is all that is on that page. In fact, it is. I should know. 8th page. Yeah. So now, let's take a more complicated absolute value inequality and let's solve it. Okay? We're going to solve it 2 different ways. The first way we're going to solve it is we're going to solve it algebraically, because algebra has yet to break my heart. So I'm a big fan of algebra. Okay? The second way we're going to solve it is using them goofy handheld things on your desk, those graphing calculators. Okay? So here we go with algebra. The steps are, the first step says, write 2 equations without the absolute value symbol, one of them equal to 5, and one of them equal to -5. So that's going to look like 2x minus 1 equals 5, and 2x minus 1 equals -5. Okay? And now we need to, step number 2 says we're going to solve both of those equations. So I'm going to add 1. I'm a writer of things because I be the teacher. So I have to write all this stuff. You probably are doing most of this work in your head, and that is okay up to a point. And that point is if you mistakes, then you should start writing more stuff down. So I get here x is equal to 3 and x is equal to -2. Do you agree with me? Fantastic. I agree? Or that? Okay? So those are the two numbers then that I need to put onto my number line. Those are my two key numbers on my number line. -2 is smaller, 3 is bigger, so -2 goes on the left, 3 goes on the right. Don't just do it however you did it up on the board. Remember that smaller numbers on a number line are left, larger numbers are right. Okay? Are we open or are we closed with our dots? We are open. Okay? So we've got open dots and open dots. Okay? Kind of like Dippin' Dots. Ice cream of the future for the last 30 years.
Grocery store ones aren't as good as the ones that like go.
Have like a fair, yeah.
It's gonna melt down.
Yep. All right. So, what is this saying? Rein it back in. I got distracted by Dippin' Dots too. Is this saying we want to be outsides or insides? Outsides because we want to be bigger. Okay? Bigger goes on the outsides. So this is an RTV. Roll the boat. Okay? The interval of that then would be from -infinity to -2 union with 3 to infinity. Okay? And that those are the algebraic solutions to this particular problem. Okay? Love it. Now, let's do that same problem graphically. So what I'm going to need you to do now is I'm going to need you to turn on your calculator. As I tell all the time, I never trust the person that used the calculator before me. So I double tap the on key. Okay? By double tapping the on key, the first tap turns it on, the second tap gets you to this screen. And you want to start yourself a number 1 new document. If it says, do you want to save it? No, you do not want to save it. Okay? And then that should give you to this screen or a screen similar to this. We are going to want to do a graph. Add graph. Number 2. Add graph. Okay? The left side of our equation was the absolute value of 2x minus 1. There are 2 ways to input absolute values into the graphing calculator. The first way is using the shortcut key. The shortcuts can all be found with this button right here. Okay? Just to the left of the textbook looking thing. Okay? That is the shortcut key. Those are all the shortcuts that we can do. One of them is an absolute value. It's the one that looks like absolute value with a box inside of it. If you click on that or just hit enter on that or scroll over to it and hit enter, you should get your absolute values. Okay? And then you would type in 2x minus, not negative, minus, not negative, minus 1. When you hit enter, you should get an absolute value, V graph. Okay? Absolute value graphs are V's. Right? Okay? The other way, is typing the letters A, B, S, and then open parentheses, 2x minus 1, close parentheses, enter, should get exactly the same thing. Is everybody with me so far on the same page? Okay? Love it. Okay? The next thing we need to do then is now as a second function, we need to put the right side of our equation. So to get to function number 2, I'm going to hit tab. That automatically pops me into function number 2. And the right side of my inequality was 5. So I'm just going to hit 5. Okay? And that opens up this wonderful tab. 5. Enter. Tab 5, enter. Okay? Now, we have 2 different functions on our graph. We need to find those intersection points. So we're going to go Menu, Analyze Graph, and I'm going to go with intersection. Okay? Now that's going to give me my dashed line. Again, as I told my class yesterday, don't get too close to the actual intersection point. You might be too close if you try and get too cute with it. Stay off to the side, click it once, and then, come on now, here we go. Click it and just drag it over, and it will show you where the intersection is. And then click it again, and boom, there's the intersection point. Then you have to do that for the other intersection point also. Then you analyze graph, intersection, and there it is, as we liked it. Shabam. So now, what this inequality, this absolute value inequality is saying, as you look upon your graph, stay with me on the front page so that we know what we're doing here. Okay? What this is saying is this is asking now, where is blue above red? That's what that inequality is saying based off of your graph. Where is the blue function above, on top of, bigger than the red function? And that happens over here and over here. Okay? So it would happen on the interval negative infinity to negative 2, and then it would pick up again 3 to positive infinity. So we get the same answer. Questions, comments, concerns, clarifications on that? Okay. What I would like you to do now amongst your tables is I would like you to do numbers 2 and 3 together. And then we'll go over them in a minute. So if I solve this number 2 algebraically, what I'd have to do is I would have to go x minus 5 all divided by 4 equals 6. And I'd go x minus 5 all divided by 4 equals negative 6. Okay. Multiply both sides by 4. That gives me x minus 5 equals 24. Multiply both sides by 4. X minus 5 equals negative 24. Then I add 5. And that gives me x is equal to 29. And x is equal to negative 19. So on my number line, those are my 2 key numbers, negative 19 and positive 29. I have filled in dots in both cases because we have the equals component. And it is asking me to be smaller than 6. Smaller means we're going inside, so it is right there. Okay. Graphically, that same problem Okay? So if I wanted to continue on this graph, that's fine. If I wanted to start a new graph, I could go Control Doc, and I can add another page with a graph in it. Either or works for us. On the left side of the first equation, that was the absolute value of. Now there were two ways to type in a fraction. First off, you could put the numerator in a set of parentheses, then the divide symbol, and then 4. Okay? Or what you could do is you could go Control Divide, and that gives you the fraction there for you. And so then you can go x minus, oops, not plus, x minus 5, and then scroll down and put 4 in. Okay? So there's that one. Okay? Then tab will get you back to that again, and the right side of this one was 6, so we have that. Okay? Now this is all great, grand, and wonderful. However, I don't see the two intersection points. So I need to do one of two things. One, I could go Menu, Window Zoom, and then Zoom Out. And I'd have to zoom out probably twice. I think it's been averaging twice until you see both of them. Or, because I've already solved it algebraically, and I know that negative 19 is on the left and positive 29 is on the right, I can go negative 30 because I like to be able to see it, and I can go 40 over there, and then I see them there. Okay? Then I can find my two intersection points. Okay? And there are my two intersection points. Okay? This again was asking me where is purple on top of black. So that would be down here is where purple is on top of black, which is the interval negative 19 to positive 29. Okay. Love it. Next one is a quadratic. Okay? Again, if we solve it algebraically, the first thing that we could do is this side is factorable. Then I can set, actually tap the brakes here, Linsmeyer. Let's go equals there. Okay? Then I can say x minus 5 is equal to 0, so x is going to have to be 5. I can say x plus 2 is equal to 0, so x is going to be negative 2. So those are the two key points then that I need on my number line, negative 2 and positive 5. We have open dots in this case. And we want the function to be bigger, so that means we are going to the outsides. So then that would be negative infinity, negative 2, union with 5 to infinity. Okay. Graphically wise, I can create a new page, a new graph, and then I can say x squared minus 3x minus 10 is my graph. There it is. And because it was with 0, I can just find the zeros. I could also put in 0 as another function and find the intersections, but I can just find the zeros too. So this is then asking where is the function, the green function above 0, and that would be in these two spots, right here and right there. So that would be from negative infinity to negative 2, and then from 5 to positive. Huh? So that is going to leave you with about 11 minutes, probably 10 after I get done talking. This back page, the third page of this note sheet, that's what we are going to be doing tomorrow in class. That's the one example that we will be doing tomorrow in class. So you have this time now to be working on your yellow homework packet, the P1, P2, P1, P3, P4, P5, P2, all that stuff. Homework packet ready to go for next week, Wednesday.